All right, folks. Today I'm going to present on a research paper that's actually from colleagues at Duke. Let me share my screen. Let's see. Can everyone see my presentation?
Yes.
Yeah.
Okay, cool. Awesome. I'm just going to move the Zoom window down so I can see you all while I'm presenting. All right. Thank you all for coming. So my name is Vitor. For the ones that don't know me, I'm a postdoc here at the Gemini Group, but also at the Department of Emergency Medicine. And today I'm going to present on a paper called Estimating the Observability of Outcomes in EHR Using External Data. This paper is actually, it's not yet fully published, is accepted to the American Journal of Epidemiology, and it was published by a few people at Duke and some other institution. But just to highlight here, Benjamin Goldstein is one of the faculty on the biostatistics and bioinformatics department. I believe he's one of the persons responsible for some of the data access initiatives at Duke. So, for instance, if you ever heard of the Clinical Research Data Mart, I hope I'm saying this right. Essentially, it's a resource, it's a curated data source that you can use to access data from Duke Hospital, both in Durham, Raleigh, from the hospital system overall. But essentially, I'm going to present on this paper. You can find the link for this publication if you want to read more, either at the spreadsheet, but also on the weekly emails that we send out. All right. So electronic health records, or EHR, are widely used in research. So it's really common for you to see papers that say that they used retrospective collected data. They tried to assemble some sort of retrospective cohort or something, especially because this system that collects data is used every day for every single patient. And with more and more, as time goes by and the push for better data infrastructures, better data governance, the institutions are making an effort to collect more and more data, to store this data from the long term for ethical reasons, for legal reasons, and many other. So it's like a good pool of data, a good source of data that is collected every day. So it's much easier to, in a sense, easier in quotations here, but it's much easier to use EHR data to do research than you actually proposing, getting funding, and starting a cohort a cohort study or a registry on your own, etc., because it's something that is already in place. It's at least we could say that it's easy to use in the sense that there is somewhat of a consistency across time in how data is collected. Of course, from time to time, the variables might change. Like, for instance, maybe if you would get Duke's EHR data from the early 2000s, it might look really different from what it looks like now, especially because the Epic software, the Epic tool, which works in the hospital, was only implemented around I want to say 2010 or 2009, I do. So probably it would look very different. But the thing is that EHRs are not designed for analysis. They are not designed for research. They are designed to store data that would be in a paper form, in a digital format. And this is really, really important because essentially you do not capture all the clinical events. You do not capture every single intervention, every single measure, every single observation, because it's not meant for research. And then that's when you get the problem of observability. And by observability, I actually say we could actually say that okay, we could question is the outcome actually recorded in the system? By an example, we can see here a patient was hospitalized at Duke, but returns to a different hospital, maybe from a different network. This readmission is unobserved in the original. Oh, sorry, I think I messed up with the screens here. Sorry. Yep, there we go. This readmission is unobserved in the original EHR, right? So you cannot actually estimate burden of disease on your population because this patient might return to a different hospital. This patient might have died, and this information is not going to be available in your EHR system. You only have data from the encounters. And this is a big problem when you are trying to do research, you are trying to do associations, you are trying to estimate causality, etc., because you're going to get biased, possibly biased estimates. And again, this is really important. Observability matters because incomplete observability leads to biased effect estimates, skewed model performance, and oftentimes algorithmic bias, especially if missing is differential by race, gender, etc. This is becoming more and more popular on how AI tends to replicate the biases that are present in the original data sources. And that's why it's important for us to understand if the data is biased before we get to the modeling, before we get to the things to actually having the predictive models. And importantly, observability is different from traditional missing data. I know that many of you are doing your data analysis for your thesis, for your projects, etc. And it's quite common that we have to look at missing data patterns before we do our analysis. We want to see if maybe there's a pattern where a person from a specific tribe, a person from a specific gender, by a specific race, etc., maybe they tend to not respond, or maybe that their data is not collected in a good quality. And we want to know that beforehand because then we can model the data accordingly. But then for EHR, you would see zero. You would see the absence of information rather than something that would be missing positive. It's a different concept where, for instance, if I was hospitalized because of an emergency situation, but like let's say I had a traumatic brain injury, I had my treatment, I had a proper treatment, and I was discharged. If I had to be readmitted because of a complication to a different hospital, my data, my outcome data, my final outcome data would not be present in the first hospital. So this missing data is not described. We don't even describe the information where, hey, we don't have outcome for this patient. This is not even present. This is not even a variable in our system. So that's where the problem comes from. In this sense, the authors from this paper, they had a few objectives where the primary objective was to estimate the observability of a binary outcome in a target EHR dataset. The secondary goal was to identify differential observability across subgroups, for instance, race and gender. And to do that, they used an external data set where the outcome is known to be fully observed. And they have done this without linkage between data sets. All right, let me get more into detail here. The core methodological idea of this paper or this methodology or this approach is that they use concepts from transportability and propensity score modeling. What are those? So transportability is a concept where you could transport the knowledge from one data set to another because you assume that it's about the same population, that distribution is similar. So you kind of assume that the coefficients, the associations, the distribution could be transported from one data set to another. And propensity score modeling is where you can use it's a method that you can use to detect the probability of being in a data set based on a few set of covariates. This can be used in different things, like the probability of you having the disease, the probability of you having being in a different group when you don't have this information. You can use propensity score matching, for instance, for creating artificial cohort groups. Like, let's say you want to compare outcomes from a population, from a retrospective data collection, but you actually want to improve your sample. You can use propensity score matching or modeling to select a subset of this population that looks really similar across themselves, and then you just stratify for their condition. Using those concepts, what this paper did is that they reweighted the external data to look like the EHR data. So they got external data source that had all of the outcomes from the patients. So all events were observed, and they tried to reweight the EHR, which is incomplete, right? They used this weighted outcome rate in external data to estimate the true outcome probability in the EHR. And essentially, they divide the observed outcome rate by the estimated true rate to get this observability rate. So the concept here is really, you know that your EHR data is incomplete. You know that it is not a gold standard. So let's try to use an external data source like a census, um, um, versus populational census, or from a clinical trial, or from a cohort study where you actually are sure or pretty much sure that you are capturing all of the outcomes, all of the events are captured, and then you can improve your data. Uh, I'm not going to go into much detail on the methods. I want to go into the applications, but essentially this is a three-step estimation procedure where they try to model this in a simulation using different parameters for the population. But essentially, they start by estimating a balancing score. So they do a logistic regression with lasso. So they are shrinking the coefficients as well on the covariates to detect the probability of being in external data. So they combine EHR data with the gold standard data, and they create a variable that says, a binary variable that says if the data comes from EHR or from the external source, and they try to predict that. Using that probability, they re-weight the data to match the EHR. And finally, they estimate observability. So essentially, the observability here, the estimate for observability is the observed event rate in the EHR divided by the weighted true rate from external data. So this is a balancing approach for you to determine or to estimate, actually, because this is an estimate. This is not a true, this is not an observed value. What is the event rate on your EHR, the true event rate on your EHR? So let's talk about real world applications. So they developed a method, they test the simulation model, and then they decided to test this with a specific health condition. So they used end stage renal disease, so ESRD, and they took a population from Medicare patients with ESRD discharged from Duke University Health System between 2015 and 2022. And their outcome was 30-day readmission. So binary, yes or no, did the patient come back or no to Duke, right? The data was CHR from Duke, and their external data were Medicare claims, which is from this data system, the system from it's the US renal disease system. Sorry, I don't have the acronym here, which is subsetted to be only for North Carolina. right? So again, what I said, they have the incomplete data set, which is the EHR data, and then they have a full observability data set, which is their Medicare claims for renal conditions. To do this, they adjust for covariates using age, sex, race, or ethnicity, length of stay. They also adjust for using the diagnostic categories, so it's the CCS codes, and they do that balancing score with the lasso logistic regression that I told you before. What they see is that you can do a pre-weighting, which if you have many covariates, that's not really helpful because you get highly imbalanced data. You can do post-weighting for essentially the most key variables. And eventually they get to a version of the model because this is a simulation that is satisfactory, which is the external data resembled EHR. All right, well, so let's go to results. So this looks more clear. So here in this table, we have the groups. So this here is stratified by sex and by race. And they have the observability estimate and the 95% confidence interval. And what they see is that males, for instance, had a significantly higher observability than females. So if you look here, 0.98 versus 0.83. Non-Hispanic Black had higher observability than Hispanic or white patients. And finally, Hispanic patients had the lowest observability. What does this mean? Let's go back to the concept. Observability is can we, actually not can we, but are we collecting the outcome data for these patients in the EHR? Is the EHR actually collecting all of the data for these patients or not? Is the data represented there or not, right? This could actually tell us information on, well, is our system serving all patient populations the same? You know, are all the races coming to our system? Is our system capturing the outcomes for everyone in an equal manner, or is our system somewhat biased, right? This is not about the amount of patients that come to Duke or the proportion of white, black, or Hispanic that come to Duke. No, this is about capturing their outcomes in EHR. So are they coming back? Are we collecting this information? What they see is that there is a difference by sex. So apparently male patients have, the data represents much better males than females. So there's something there. And if you actually look at Hispanic patients, it's the worst observability of them all. So something is happening, or something is happening to the way that we collect the data or the way the health system is working, that Hispanic patients that come to Duke with a end-stage renal disease, their outcome is not represented in our system. So if we would go and use their data to do some modeling, maybe the model would say that the Hispanic patients would, it would have a poor outcome rate. But actually, that is not true. That is a artifactual conclusion based on how the data itself is already biased, right? I'm not trying to imply reason here, but I'm just saying that this is a way for you to actually see how the data itself is not complete, right? So you can take more meaningful conclusions. Any questions here?
Joao, I think it's like not more of a question, it's like a point of understanding. So this would help you like determine the missingness in the data, like prior to you determining it, or is that what it means? Like if you get a more observability, for example, that means like less observation will have missingness. Is that the point? Or
That is the line of thought, yes. But then the important piece is missing is when you actually have the data point there that is blank, right? So if you go to a TBI patient and you don't have information on their Glasgow outcome scale score, sorry, that is missing. So that's an
Mm.
NA there.
Mm.
But observability is actually the patient itself. It's not accounted in the system, right? So the patient does not return to the system. The system does not capture all of the patient information. So you don't even know if they are missing, right?
Okay,
Because
that's
something happened, like let's take an example from a TBI patient at KCMC. So the patient went to KCMC because of a TBI, the patient was treated, the patient stayed in a hospital for, I don't know, 20 days or something, or more or less, but the patient was discharged, okay? Eventually, 30 days after, this patient was readmitted, or this patient died, but they went to a different hospital.
mhm.
If you went and actually went to about studying the 30-day readmission for your patients, you would think you would not be able to capture this readmission because the
Yeah,
system itself cannot capture that
okay,
because they were readmitted to a different study, to a different hospital. The way
okay.
that you could control that is using a methodology like this one, where you have an external data source that estimates this 30-day readmission overall. You
Mm.
could use this external data source, even if it's a smaller data source. Like, let's say someone did a clinical trial, someone did a cohort study in a separate place in the Kilimanjaro region, or maybe in other region in Tanzania. And they saw that the 30-day readmission rate was about 10%. And you can use their estimate and balance your estimate on theirs, considering the covariates, considering the patient characteristics, and then you can estimate your observability rate, which would then lead to less biased estimates on your readmission rate, on your outcome rate. Does that make sense? Make sense?
Yeah, it does make sense. I just have a follow-up question. So for you to be able to do that, is that a coding level skill, or you need like to have another extractor? Is it a code, or is it, do you understand? Like,
Yeah.
sorry if
So
I'm repeating it.
so no, don't worry, don't worry. So what they do is that they tried a few different parameters to get the best version of each model, etc. But essentially, you combine both data sets, let's say KCMC and this clinical trial, this cohort study that we're talking about. Of course, you would have to have all of the same covariates. You would have to have similar variables across them. And you use a binary variable, which is the data set variable. Is it
Mm.
KCMC? Is it external? And you try to predict external with a lasso. That coefficient, which is going to be like not coefficient, but that probability of being external based on the other variables, is what you use to adjust the observability rate from one data set to another. And eventually, you can get to something that is an estimate of the rate of observability considering this outside data source. So
Okay.
it is a way for you to transport the information from one system, from one data set to another, sort of adding a weight to your outcome. Instead of saying that your outcome would be the 10% that we talked about, using that that weighted true rate from the external data, maybe that turns into be like 7%, right? And that is
Okay.
going to be really meaningful when you want to build those retrospective cohorts. Like Duke has a data set for about 4 million patients, 4 million patients that visit Duke from the last 20 years. But again, we don't capture all of the information. If you, let's say, I want to use that to create to understand what is the impact of intervention in my population. Well, you can do that, but your estimate is going to be biased because this was not designed as a cohort study. This was not designed as an intervention study. So your sample, your data collection is already kind of biased in that sense, right? So it's an artificial way, and it's an adjustment that you can do to eventually get closer to a experimental design to a prospective design using retrospective data.
Yeah, it sounds like too much. That's
Yeah,
yeah, because I'm
yeah,
just trying to think like ideally, maybe I have a data set, my EHMS data, and I'm trying to do this. Now I'm trying to digest, and it's a little bit, it's a new concept.
yeah. Yeah, it is
Yeah.
new, but let's say like if we could put
Yeah.
it into a more practical example, like we have the PrACT study, right? So the clinical trial. Even
Mhm.
though it's focused on alcohol, we do collect other measures, and we could assume that because this is specifically we randomize patients, we follow patients, etc., we could assume that the data collection or the quality of data collection is better compared to the EHR because EHR, the nurse is taking care of the patient, and maybe they forget to add the data at the time point, or the data is not entered because the family member said that the age was 30, but it was actually 29, etc., etc. So you could adjust this patient population that comes from a similar sample with the age that we see in PrACT to adjust the age that we see in the EHR. So essentially, you
Mhm.
would get a better representation, a better quality of your data, and eventually you would get a better quality or your outcome estimates as well, right? So that's the general feel of it, the general thought process, but it is more focused on the outcome rate, the observability rate, rather than the actual covariates. That's the
Okay.
idea.
Okay.
Thanks for the question.
Yep.
Okay. So in terms of discussion, this method provides the first formal framework to quantify and compare observability in HR. So this is pretty cool. This is really novel as well. So maybe we can see more of this in the future. It is good because it highlights hidden biases in the health system data, which we don't tend to see. We just assume that the health system data is good and let's use it. Um, you can also see subgroup differences in observability, which can pose risk for model fairness and validity. Um, and the good thing is that it works for any binary outcome. Like if you want to estimate mortality, risk hospitalization, adverse events, etc., this can be used to do that. Um, you can use any external data set with full outcome data. It's like I was saying, like claims to like this is claims for probably health insurance. This is randomized control trials or cohort studies because these are usually very high quality in terms of capturing the patient flow through the system, their outcomes, because you are following patients, because you're paying close attention to these patients, and not because this is a designed process. And especially one thing that I would like to highlight is that you don't need to link patients. This is a major problem when you're doing studies because, like for instance, for Brazil, we have a huge set of data for our patients, but of course it's all anonymous, right? De-identified. We could probably try to do something like this to take the data set from Brazil from the hospitalization system and try to balance some of the estimates that we get for a condition. If you get a randomized control trial, if we have a cohort study that could adjust the outcome rate to our system. And thus, we would get um, results that are more meaningful, that are beyond your conclusions that you could get from a cross-sectional study, from a retrospective study, etc., because you are adjusting for these estimates. Of course, there are limitations. As we were talking about, you need a very good quality external data with full observability. So sometimes that is not going to be available for your study, for your objective. Um, because the way that this works, you need to have overlapping covariates that are measured consistently across data sets. And this is also a problem. Like, how is TBI severity measured at KCMC versus at this clinical trial that we were talking about? How is readmission rate measured in the general Brazilian Datasets data versus the clinical trial, the cohort study that we're going to get. We need to find studies that have this clear definition of how things are measured. And of course, there are a lot of assumptions, as William, you were alluding to, like this is statistics, etc. But we are assuming a lot of things. We are assuming that the data, that the populations are similar enough. We are assuming that the variables are collected in a similar fashion. Of course, this is an estimate. This is going to be a limitation on itself as well. And then finally, as a conclusion, I just took a quote from the actual paper, but they say that observability is a hidden but crucial dimension of data quality in EHR research. And essentially, this method would give researchers a tool to measure it, test for bias, and ultimately build more trustworthy prediction models. This is going to be really, really important for all of these new AI tools, these new predictive models that, well, we don't really have a population level data. So let's take this hospital data that was collected 20 years ago and use it to build predictive models. Is it good? Is it bad? Is it going to work for everyone? Is it fair? Is it valid? All of these are, of course, important questions that could be potentially answered or explained by this observability issue. You could adjust your model based on the observability rates as well. That's what I had for today. Thank you all for listening. If you have more questions, please feel free to ask.
Yeah, mine is not a question. I feel like maybe we might need a follow-up like for this because the idea that I've created in my mind to this point, Joao, is this technique can help you to filter out your EHMS data and see if it fits and it's good to be used. That's the superficial idea that I was able to
Yeah,
extract.
yeah,
So it
yeah.
helps you really understand that context. But now, like the only thing that I think maybe I missed it somewhere, I know you have tried to explain, is like you always need to have a mirroring data that you're going to compare and you're going to weight where that is going to help you extract the coefficients.
That's right.
So I don't know, like for example, if I'm having my data, will I be creating something like an data extraction sheet that is going to be used for me to be able to calculate my observability? Or do we have already templates for specific data sets? So that I don't know if I got that right.
Mhm.
But I feel like this is a very game changer, especially for we have students here. I've never used EHMS data in any way, but I feel like that will be something very interesting if we could have as I was saying in the beginning, like a follow up on how really to do this.
Yeah, and I mean, let's go. Your question has multiple parts to them. I guess that one thing we could talk about is how accessing this external data source is already sometimes an issue. Accessing EHMS is sometimes an issue because there's identified information. Sometimes you gotta pay for it. Sometimes you don't even have this good quality external data source to use.
Mhm.
Those are all barriers, right? But if you can cross all of those barriers, the good thing is that you don't need to link patient data. So that's already a very good, very positive of this approach, a very good advantage,
Mhm.
because you can de-identify the information, removing patient IDs. You could anonymize age, dates, etc., and use those data in a safe way. So it's already in an ethical clearance aspect, an advantage on its own. The second
Mhm.
part is you asked about the data extraction sheet, you asked about the code, etc. The way that I understood reading the paper is that, let's say you are using a set of 10 variables on your predictive model, right? You used for the TBI probably like 20, 25 variables, if you give or take 25 variables, I don't know. You would then collect this same 25 variables from your external data source, from this cohort study, from this clinical trial, which is your gold standard. You would combine them like you did for the trauma, the TBI registry, the TOC registry, and the trauma registry, the PrEP registry, right? You would combine them as you would basically do that in your analysis, but you would create a different variable that is a binary saying, is this from KCMC or is this from the external data source? You would then fit a logistic regression to predict if the data comes from the external or the internal, and that would give you a probability, right, for each patient. That probability and those coefficients for the variables can use to adjust the adjust the external data to match your EHR data. So as I was saying, maybe the the average age that you have on your registry is 25 years old. But then if you look at this clinical trial that was done in the same population, you see that the average age was 30 years old. Using that difference in the means, you can adjust your poor quality data, which is our EHR data, to your good quality data using that logistic regression. So you would use the coefficients and the probability of being one of those cohorts to adjust your covariates, to adjust your model, essentially adding weights to your estimation. Of course, there are details there that I probably missed and skipped. But that's the overall thought process. Like if you have both data sets, if you have the same variables, you could then simulate and you could try a simulation process with different parameters and use those to adjust your own data set. That's the general idea.
Okay. Makes sense, Joe. This was really helpful. Was really
Of
helpful.
course.
Thank you.
And of course, it's easier said than done. I'm sure
I
that
know.
if I were to try this, it would be a nightmare. But
I
again,
know.
this is a interesting part that, like, if we want to do business in the future, at least someone has started doing this, so you
Yeah,
could try to mimic, right?
yeah, I know. It's the doing part is always the hardest one. I know. Like the theory part, it's really interesting and it's catchy. I agree. Yeah,
Yeah,
yeah. That's it from me, Joy. Yeah.
awesome. Thank you, William. Anyone else questions? Nope, that's fine. So just